Okay, I'll just give you a brief rundown on my background. I basically grew up on a fishing boat in the northeast of the United States in a little town in Maine. And that was in the 70s. And at that time, we could basically catch fish anywhere. We could catch flounder, we could catch codfish, lobsters right close to shore. But over the period of time that we started building bigger boats and heading offshore, we saw a lot of those stocks start to diminish. And over the years, we watched various levels of pollution that started to take over along the coast, which was from stormwater runoff and from urban development and sprawl. And the fish started heading offshore, so we built bigger boats, and we moved to the Georges Banks and to the Grand Banks, and that's where I spent basically almost 20 years. And then with the Hague Line, which probably none of you really know about, but a lot of the Georges Banks, where we used to fish, was given to the Canadians. So at that time, that's when I decided that I'd get out of the fishing business. Went back to engineering. I'm a licensed ship captain, merchant marine officer, marine engineer. So I went back to the engineering side and decided basically that there was a lot of room in the fuel efficiency of a lot of these vessels. A lot of the fishing vessels that I deal with, and I'm finding this predominantly the same around the world, are older vessels. In fact, last month I was on a vessel that was built when I was 16 years old, 40 years ago. This vessel has had 3 engines, but it's the same vessel. Same hull, doing the same things. And going through their energy audit, it's amazing the amount of how inefficient this vessel is. It was built in a time when diesel fuel was 37 cents a gallon. And fish prices were predominantly high for that time, so the level of profitability was very high. Now it's completely the opposite. Fuel expenses are up, fish prices are low, and they have to spend a lot of time now being the business people that they never really was. Back in the 70s and 80s, if we wanted to make more money, we just stayed out longer and fished harder. But now with catch shares, quotas, limited days at sea, they have to really be watching their overhead. So anyway, I decided to take a lot of the engineering and go in and look at different ways to help out vessels. We're also working with a lot of tugboats and a lot of ships, not just fisheries, but the fishing is something that I am always involved in and wants to be, so I steered a lot of this towards the fishing. Let's see if we can change the slide. Nope. Okay. So the main objectives, what do we want to do? First of all, I'll say that the first systems that we developed to help limit and control fuel worked well, but the problem that we had was we didn't have documentation data and baseline data on the vessels. And what I was finding was there was many captains and many owners that had these vessels for years. They could give you an idea, but they really didn't know how their fuel was being used and why and where, as opposed to towing, non-towing, laying to, steaming. So the first thing that, after we went through a bunch of boats and we did a lot of system work, then I realized we had to get into the documentation and analyzation before we could actually install any equipment and improve the vessel. So the main objective, you got to document, that we can analyze, and then you can move on to measurably improve a vessel's fuel efficiency. Reduce and document exhaust emissions. I know that exhaust emissions are becoming a big issue worldwide. In the States, in 2014, the new regulations are going to what they call Tier 4 for marine exhaust, and that's extremely difficult to achieve. There are no approved rebuild kits available for engines now below 2012. So that means a complete repower. When those engines go down, that means a complete repower after 2014. Monitor and control fuel consumption in real time, on board and ashore. Now that means if we can't measure it, you really can't improve it. You have to have the ability to monitor it on the vessel so you can see it in the real time, and then we developed the technology of where we could have that transmitted back ashore. Many of the boats that we deal with have a fleet manager, shore captains. This technology allows them to see where the boat is, how much fuel is being burned, and basically being able to regulate what the vessel is doing. Then after that, to document and produce fuel management, just the methodology of the fuel management. Being able to consistently get the data and then have captains and crews that will develop the techniques so that everybody is making sure that it's working properly. So we have labeled what we call a green vessel conversion, and basically that's a multi-level approach to measuring, monitoring, and reporting fuel usage with the goals of reducing the fuel usage, reducing the exhaust emissions, increasing the operational efficiency, and improving fleet management oversight. So again, the effective fuel management requires a data collection on how much fuel is being used. What we really found out is that most of the boats that I've gone to and we've analyzed, they could tell you what they did for a trip, but they couldn't really tell you where they used it. So that we'll get back to that later on. And then what areas of operation impact the fuel use? Most of all, the vessels that I'm dealing with are trawlers. So we needed to be able to measure, is the trawl gear efficient? Is there ways to change nets? Is there ways to change how they tow as opposed to fuel use? Manual methods of measuring the fuel usage we found simply didn't tell us enough information. They didn't tell us how much fuel was being used, whether they were steaming or whether they was fishing. Didn't tell us in the case of dual engines on vessels if one engine was in tune to the other engine. I found one vessel that one engine was burning 30% more fuel than the other. Performing an operation versus another. Is this boat lobstering? Is this boat steaming a lot? Is this boat towing? Is it towing scallop drags? Is it towing trawls? What is it doing? And then particularly we had boats where they run double crews, so is it crew A versus crew B on similar trips. And believe it or not, that was a problem on two vessels, was that one crew and captain was burning 20% more fuel than the other one. So there was a big variance in how the vessel was being operated. So again, you can't prove what you don't measure. Now there's some modern engines now, if anybody has the newer versions, they are equipped with what's called a CAM bus, which will have a fuel meter. And basically that's telling you how much fuel is running through the engine. It's not necessarily telling you how much fuel is being consumed. It really doesn't give you a backdrop as far as the amount of fuel being used, to how many miles are you going, and how fast are you going. Some of the newer engines do have torque installed on the shafts, and some have RPMs, but not on the, some do have an RPM gauge at the shaft level, but most don't. None of them have an exhaust emissions baseline, and none of it really takes into effect the quality of the diesel fuel. Around the country, around the US, we found a big variance in the quality of diesel fuel. So, you know, with bad fuel, the economy goes down. So fuel controls. The first thing that we do is go in and say, okay, we have to measure the direct fuel consumption. Some vessels were equipped with fuel meters, but most were inadequate, so we had to go in and install new fuel meters. That allows the data acquisition. Then we can get a statistical analysis, and then we can do that right back at our point of operation because we can do the online management. Now this is a picture of a typical monitor that we use that would go in the wheelhouse. There's a lot of information being on this as far as engine RPM, miles per gallon, amount of fuel being used, actually being consumed, how much fuel is on board. So this is something that the operator, the captain, will look at, and basically he can use this information, whether you're towing or steaming, to arrive at the highest level of efficiency. This is a typical graph, fuel graph, that would come up on that same screen. It changes different levels of information that it will provide. Now this graph on the right-hand side was actually the position or the route that this vessel took in the span of the information that's on the graph to the left. Now on the data on the extreme left in the top corner, it'll tell you speed, gallons per hour, miles per gallon, and the shaft RPM. Now this particular vessel had a 7-to-1 reverse gear, so that's why you'll see 226 RPM, is it? Yeah. Now the data on the right-hand side is the actual data of that line that you show on the map. The duration of that run was 2 hours and 42 minutes. He ran 7.62 knots, 5.78 gallons per hour, 1.32 miles per gallon, and he averaged 199 RPM. That line on the left, the line on the left, his route, is what is shaded in pink on the chart. Now, in this particular day, his total time of accumulation, the time that you see on the chart on the right was what time he steamed. Then he made 2 tows, and that's where you see the fuel go up. The red line on that chart is the fuel increase. So he made a tow, then it took a drop, he hauled back, and then he made another tow, and he hauled back, and then that flat line at the right is when he ran back in to port. So now he can match up. If he's got 2 different types of nets, he can match up what the weather conditions were. He can work to get the red lines and the blue lines, which is where ultimately the best efficiency is. He can actually work that. Now, what I did on this chart, for an example, is this was an actual tow that he made, and he was about 20 miles offshore when he made this tow. But shaded in pink on the left, again, is the actual tow route that you see kind of as the squizzle mark from point A to point B. Now, in the data in the center of the screen, the duration was 3.52 minutes. He towed at an average speed of 3.2 knots. He burned 9.49 gallons per hour, and he averaged 0.32 miles per hour. So for that tow, he burned 36.8 gallons, and he covered 11.7 nautical miles. Now, again, now he can start to compare tows, and he can start to compare where he fished, how much did he catch, what was the pounds that he caught there, and actually he can work out what it cost him per pound to catch that fish. This is an analytical report. Now these reports can be made to really put up any amount of information. But on this one, you can get your consumption per gallons or per liters. It will work per liters. It's just a measure of the setting the software up. Consumption with speed, with no speed. For example, when you would be hauling back, if your vessel didn't move much, you'd have a factor of no speed. Your average consumption per gallons per hours. Your economy, it gives you a percentage. The data on this chart can really be set up to meet any individual vessel. And there's a lot of them that have different parameters, so you can customize it. Now, the way to control a lot of this efficiency, you have to have shaft torque and RPM. This is another screen that will take over and will give you, this is set up with twin engines, and now you can dial both of these engines in to get them exactly tuned the way you want them. That's one thing that we found was very important, because we'd find vessels that were actually, they were towing RPM-wise a lot harder than they needed to be. So they were burning more fuel that they really didn't need to burn. They also were steaming a lot harder than they needed to be. And in one case, we found a vessel that was not steaming hard enough. He thought he could hear the sweet spot of the engine. He was right in the right spot for RPM for the best economy, but he was actually about 200 RPMs less than where he should have been for that vessel. Those are some things that he just couldn't tell on board. So the shaft torque and RPM, adjusting the vessel's speed and trim for maximum fuel efficiency. That's what all of this data, screens, the chart screens, the live time, everything in real time gives you the ability to do. It gives you the ability to equal load sharing adjustment in twin engine applications. That's an important factor because, as I said before, we have engines, if one prop is out of tune, that could change the whole ballgame. Monitor your marine gears and shaft loads. Sometimes that'll help out to minimize a gear problem. If you're loading that reverse gear up too heavy, so that could help out on maintenance. And it gives us a baseline information for any upgrade for efficiency that we may do. Now, the typical challenges that we run into, number one, we run into the age of the vessel and the engines. The average age of most of the vessels that are still fishing that I deal with is around 32 years old. They were built in a time when fuel and expenses were a lot lower. They also can be what I call a SUV. They're kind of like a utility vehicle. They may go dragging, then they may shift over and go lobstering. They're kind of a utility platform. And what might be good for one wasn't good for the other. So they're not really tuned in. The power, the props, the hulls really wasn't never put together for efficiency. That comes down to the primary vessel use. Was it built for dragging? Now it goes lobstering. Was it built for netting? And now it goes dragging. How was it built? Propeller and hull efficiency. Many times when these boats were built, the owners picked out the hull they liked, and then one of the engine companies gave them a deal on the engine, and then they needed a prop that never was really ever tuned up. How much does a vessel weigh, and how is it being loaded? How much ice it has to carry, or how much catch it has to have when it comes in. How's the vessel being loaded at that time? That comes into play. Mechanical maintenance. How well is people keeping up on their engines, injectors, filters? How good is the diesel fuel being maintained? Hull maintenance. Bottom paint. Bottom paint is a big thing that we deal with. Fishing gear. With this information of this type of measurement, you can find out the efficiency of what gear you're towing. And then one of the big challenges at the end is once this all gets put together, that the crews and the captains continue on the program. So improving fuel quality, you know, that's one of the first things we do is we go in and we have the fuel tested. What is the actual quality of the fuel? And on a scale of 1 to 10, we'll find a 2. We'll find a 3, and we'll find it as high as a 9. But I can't say that we rarely ever find a 10. So that's the first thing. You know, how good is the fuel? The second thing we go on to is bypass oil filtration. Now that's been something that we've been working on now for several years, and actual damage to the engine will happen in the 14 to 16 micron range of particles in the oil. A typical full flow oil filter will only protect you down to about 25 micron. And the bypass oil filtration that we use will take it all the way down to 2 micron. That will extend out your oil changes. We got some vessels that are going out 7 to 9 times of where they normally would have changed their oil. They're getting about 7 to 9 times more duration on their oil. Hull bottom coatings. You may haul out the boat, and a lot of boats that I'm dealing with, they may only go to dry dock once every 2 years. We've installed bulbs on the bows. They'll help your efficiency. Quart nozzles. That's a big thing now that we're working with on a lot of draggers now in the States because they were built without nozzles. We're working with hydrogen, injecting it into the air streams to help the fuel burn better and to lower the exhaust emissions. A relatively new technology is the emulsified water into the diesel fuel. I'm going to talk about that right in a couple more slides. And then we're doing a lot with LED lighting, and an LED lighting upgrade as far as deck lights, onboard lighting, can reduce your generation fuel by about 20%. So we went over a little bit about improving the fuel quality. There's a lot of very good additives that can bring that fuel up to a good burn rate. Make sure you got good water separators. We look at all of that. Better diesel fuel, going to improve how the engine wears, and it's going to add horsepower. Bypass oil filtration. Basically, in some you could reduce your fuel oil cost and your lube cost by up to 90%. It's going to help keep the engine clean, and there has been documentation of about 5% reduction in fuel consumption. The additional soot in the oil creates friction, so keeping the oil clean will help the engine run better. Hull coatings, this is too often overlooked. Even a light slime that can be, you can hardly even see it, can add 8%. And if it gets heavy, as much as 18%, it takes more power to run. And typically, I find that vessel operators don't pay much attention to it other than in between dry dock. Adding bulbs on bows. Now, of course, some of the boats we're doing lie-downs around 100 feet in length, but it can reduce your fuel consumption. The boats tend to handle better in a seaway. There are some people that have built bulbs on in the 45-foot range, but really over 60 feet is where they see the best gains. Quart nozzles, that's basically the brand name. They've always been used for a long time on towboats, but the increased pulling power, and you really can give you a tremendous fuel savings and a very fast return on investment. Injecting hydrogen is very effective. You can reduce fuel consumption up to 30%, and the exhaust emissions. Basically, you can take out the NOx emissions go away. Reduce soot in the engine lube, and the engines run a lot smoother on it. The emulsified water diesel, that's relatively new. We just started working with this, but you can look at saving between 20% to as high as 40% on the fuel bill. But as I said, it's relatively new, and we're going to work with it a while longer. There's one thing that does happen is it does create a loss of power. So we don't know exactly how that's going to work. I think in vessels that do a lot of steaming, I don't think it's going to matter, but a lot of vessels that do a lot of towing, it probably will. Again, the LED lighting upgrade, save fuel. Now, return on investment, this is one that I just did. And we looked at installing hydrogen, installing bypass oil filtration, and a nozzle. And this was just a typical return on investment, 240 days at sea. They were doing 2,800 gallons per day, and so he was going to burn 672,000 gallons. So we just set it up for a 10% savings. So the total refit bill was going to be $186,000, and so he's paying for it well in the first year. Now, the opportunities here is there's a lot of technology, there's a lot of combination of methods, there's a lot of availability to reduce the fuel consumption. Now, the vessels and entire fleets, there is profits to be had to the bottom line, and there's faster ROIs. And one of the biggest potential of opportunities that we're seeing is there seems to be more interest on government agencies now to aid assistance in upgrading vessels. It kind of comes back into, at least in the States, there's a lot of subsidy money that they put into the fishing industry, so they're looking at redirecting a lot of that subsidy assistance into vessel upgrades. And I think that over the next probably 4 to 5 years, a lot of these boats are going to have to be upgraded, because they're not going to be able to stay in business if they don't. That's basically it.
Okay.
That's it.
Thank you. Thank you, Jeff.